Hi friends, it's me again, Alex, a Python developer from Pinest. Today I'm sharing the top 10 essential Python features every developer should know. Perfect for beginners building a solid foundation and pros revisiting the basics. Clean, efficient and elegant code starts here. No fluff, just practical examples. From boosting readability to avoiding common errors, we've got it all. Let's start with list comprehension for writing concise and expressive code. It's a powerful feature in Python that lets you create lists in a single readable line, making your code both shorter and clearer. Here's an example. Let's first look at a classic way of solving a task using a for loop with a condition. For instance, let's process a matrix to filter rows where the sum is divisible by 2 without a remainder. Here's how it looks step by step. The first one iterates through each row of the matrix. The next one checks if the sum of the row is divisible by 2. And the last one, if the condition is met, adds the row to a new list. Here's a working version, but it's a bit verbose. Using this list comprehension, we can make this code more concise by combining all actions into one line. We can filter the rows and calculate their sum in a single step, making the code not only shorter, but also more readable and efficient. This approach simplifies the logic while maintaining clarity. List comprehension makes code more compact and readable, but overly complex logic can reduce clarity and maintainability. Use it wisely, prioritize simplicity and readability, even in a concise code. The second step is to simplify the code using the Walrus Operator. The Walrus Operator allows assignment to be done right within an expression. It's especially useful when you need to avoid repeated calculations in loops or conditions. In this example, we calculate the square of the value and check if it's greater than 50. However, the code uses multiple nested conditions, and the calculations are split across different lines. By using the Walrus Operator, we calculate the value to the power of 2 and assign it to the square variable directly within the condition. This eliminates repetition and makes the code more concise and easier to read. In conclusion, inline assignment streamlines the logic of the code. It's perfect for combining calculation with condition, and complex expression can reduce readability. So, we've explored inline assignments and how they simplify the code. Now, let's take a look at another tool that will help make handling conditions even more concise and elegant: match case. When there are many conditions in the code, if-else can quickly become cumbersome and hard to read. With the introduction of match case in Python 3.10, we can write cleaner and more structured code, avoiding unnecessary duplication. In the code example, we see many repetitive checks for keys and type matches. Each new condition makes it harder to maintain and understand. With match case, the code becomes compact and much easier to read. We can directly match the data structure, avoiding manual with-instance checks and key lookups. It also makes it easier to add new cases or conditions in the future. It's also fantastic for working with regular expressions. This flexibility allows you to process text data, split strings, or extract desired values, making the process of adding new conditions intuitive and convenient. Now that we've seen how easy and beautiful it is to work with conditions, let's focus on the importance of the else block in try except finally construction. It's often an underrated tool that can greatly simplify exception handling. Consider a payment processing system where each transaction needs to be executed accurately and with minimal risk of errors. Using the try except else finally block allows you to structure code clearly and separate error handling, success, and mandatory actions. In the current example, the logic for success, errors, and mandatory actions are all mixed together, which reduces readability. Logging the successful completion of the transaction directly inside try block is not always the clearest approach. By using else and finally blocks, the code becomes much more structured. The success logic is isolated and doesn't interfere with the main transaction, making the code easier to read and maintain. In summary, the success logic in else is clearly separated and executed only when there are no errors. Also, errors in additional actions won't affect the transaction. And the last one, it's easy to add new actions for successful transactions, such as notifying the customer or etc. We've seen how to make the code more reliable and flexible. Now let's talk about saving memory with slots. Are you working with millions of objects in Python and looking to save memory and improve performance? Let's explore how. Slots can help you manage class attributes efficiently and minimize overhead. In this example, each customer object stores its attributes in the dict dictionary. While this is convenient, it consumes a lot of memory, especially when you create a million objects. By using slots, we eliminate the need for dict dictionary, significantly reducing the memory used by objects and improving performance. With slots, only a fixed set of attributes can be defined: name, email, and age in this case. Speaking about advantages of slots, at first each object takes about 80 bytes instead of 400 bytes. For a million objects, that's a savings of approximately 320 megabytes. Second, assessing attributes is faster because they are stored in array instead of a dictionary. And the third one, you prevent the accidental creation of extra attributes, reducing the chance for errors. Speaking about limitation of slots, at first you cannot add attributes not defined in slots. Second, if you use inheritance, you must explicitly define slots in the child classes. And the last one, it's not compatible with classes using dict or vecref. And the last topic, when you should use slots. At first, if your class has a fixed set of attributes. Second, if memory usage is a critical concern. And the last one, if you need to prevent the creation of dynamic attributes. So, is everything clear? When memory is precious and attributes must be strictly controlled, slots is your go-to solution. However, if the task involves creating immutable objects, a data class with frozen true parameter is the perfect tool for building reliable, unchangeable data structures. What is a data class? A data class is a decorator that simplifies the creation of classes for data storage by automatically generating methods like init, wrapper, and equal. When it's critical to ensure that an object's data remains uncharged after creation, say for auditing for strict business logic, the frozen true parameter makes the object immutable. For example, a class like invoice with frozen true parameter prevents any modification to its field after initialization. If you attempt to change the data, Python will raise an exception, safeguarding your data from unwanted changes. Advantages of frozen true: data security. Once created, the object is protected from accidental modification. Convenience. No need to manually write construction or comparison methods. Auditing. Immutably ensures original data integrity, especially critical in regulated systems. Disadvantages of frozen true: lack of mutability. Objects can be updated. Dynamic modifications require creating a new instance. Overhead for changes. Any change to the data required a fresh object, which might be less efficient in certain workloads. When to use frozen true? When your classes are primarily for data storage. When immutability is crucial for security, such as in financial applications. For reliable data auditing, where the integrity of the original data is critical. By choosing the right tools, slots for memory efficiency, or frozen true for immutability, you can craft Python code that is not only performant, but also robust and secure. But what if you need to optimize API requests and reduce waiting time by reusing already received data? In this case, LRU cache becomes an indispensable tool. It speeds up your code by storing the result of function calls and reusing them when the input data remains the same. For example, imagine a getWeather function that fetches weather data from an API. By applying LRU cache, a repeated request for the same city can be retrieved directly from memory, eliminating the need for additional network calls. Advantages. Performance. Reduces the number of API calls, speeding up the application by reusing cached results. Resource efficiency. Minimizes API load and reduces network traffic. When to use? Expensive operations, perfect for network requests or computationally heavy functions. Rare data changes, best for scenarios where data updates infrequently, allowing efficient reuse of results. So, when we talk about improving the performance and efficiency of an application using caching, it's essential to recognize that working with external resources like APIs isn't always error-free. This brings us to a critical topic: logging. Logging is your go-to tool for tracking errors, analyzing performance, and ensuring application security. It's indispensable for debugging and monitoring, especially in complex systems. Why log? At first, quickly identify and understand the root causes of errors. The second, measure the execution time of critical operation. Third is monitor user and administrator action for added security. And the last one, simplify troubleshooting with detailed program behavior insights. In this example, we use different logging levels. Debug for detailed operational information. When a process starts. Info to log successful operation. Error to record errors and exceptions. critical for several issues needed immediate attention. Also, you can integrate your logging system with dashboards. Tools like Grafana enable real-time monitoring, making it easier to track key metrics and system events. Logging isn't just a tool, it's a lifeline for building robust, maintainable, and secure applications. Now that we explored logging and its importance for tracking errors and simplifying diagnostic, let's dive into another fundamental concept in development: abstractions. Why should you use abstractions in Python? How can they make your code more flexible and scalable? Let's break it down. What are abstractions in Python? Abstractions help developers design systems that are easier to extend, support, and test by focusing on what needs to be done rather than how it's done. A common example is creating a universal database interface using abstract classes. How does it work? Abstract class. Define a class, e.g. database, with methods like connect and execute query, but leave their implementation empty. Specific implementation. Subclasses, e.g. SQLite database or PostgreSQL database, inherit from database and provide the specific implementation for these methods. Universal function. Create a function like fetch data from DB that works with any object implementing the database interface, regardless of whether it's SQLite, PostgreSQL, or any other database. By leveraging abstractions, you can build flexible, scalable systems that adapt to the future requirements without overhauling the existing codebase. It's not just about making your code work, it's about making it future-proof. We already explored how abstractions can improve the structure and flexibility of your code. Now let's dive into another essential Python tool, Enums. Enums not only makes your code cleaner and easier to read, but they also enhance its security by strictly defining possible states and simplifying state management logic. An enum is a symbolic name for a set of unique values. It helps you create a limited set of predefined states that your code can safely use, eliminating errors caused by invalid values. How can enums be used? Define order states. Use an enum to define all possible states of order, e.g. pending, shipped, delivered, and etc. Check state transition. Implement a method like isValidTransition to validate if moving from one state to another is allowed. Why use enum? Clarity and security. Enums reduce errors caused by incorrect strings or numbers. For example, instead of passing delivered, you'd use order status delivered, ensuring consistency. Readability. Enums makes the code self-documenting. You instantly understand the purpose of order status shipped without relying on comments. Ease of maintenance. Adding or modifying states is straightforward, making it easier to extend the system over time. Enums in Python are a powerful way to define and enforce control sets of values in your code. They boost readability, maintainability, and security, making them a must-have for any project where state management plays a key role. Each of the topics we are covered is a key part of a modern Python developer's toolkit, but remember, this is just the tip of the iceberg. Behind each tool lies a world of deeper possibility. Speaking about Dataclasses, we can integrate them with JSON, creating immutable objects, and more. Speaking about logging, configuring complex formats, rotating logs, and integrating with monitoring systems like Grafana. These tools don't exist in isolation. Together, they help you create solutions that are adaptable and robust. Mastering this basic isn't just about writing better code, it's about building systems that makes a real difference. That's all for today. If you found this video helpful, don't forget to like and comment, because your support means the world to us. And what do you think of this new format? Share your feedback and we will keep bringing you even more practical content. And of course, subscribe to our channel so you don't miss any updates. Let's continue exploring the world of exciting Python development together. See you in the next one, friends.